this is Geometry Final Exam Review 2. We're starting in Module 9, which is transformations. And that first one, what we're going to be doing is we're going to be working with a triangle ABC with these coordinates right here. And for that triangle, I'm just going to graph those coordinates first. So I'm going to go over 4 up 2 and graph that first coordinate. I'm going to go over 1 down 3, graph that second coordinate, and go up 3 on the y for C and graph that third coordinate. And then I'm just going to make lines to connect the triangle. So this is A, B, and C. And I'm also going to come down here and write out A, B, and C, which is for 2, 1, -3, and 0, 3. Now, the reason I wrote those arrows is because we're going to be following this rule to graph the triangle. So what I'm going to do is I'm going to go 4 to x minus 3. Well, that 4 is in the x position, so I'm subtracting 3 from it, so it becomes 1. So 4 minus 3 is 1. And then the y, I'm going to be taking away 1 from the y position, which is where the 2 is, so now it becomes 1, 1. And I'm actually going to graph that in a different color so you could see here's where A prime comes in. Alright, that second one, B, I go from 1, which is, I have to subtract 3 from it, so 1 minus 3 is actually -2. And then a -3 minus 1 is actually a -4. So that's our B prime. And if I graph that, -2, -4 is here, and that's B prime. And then the last one, 0 minus 3 is -3, and 3 minus 1 is 2. So I'm just going to go over 3, down, up 2, sorry, it's positive. And that's C prime. So we can see this triangle is the same size still, it's just translated. This is a translation. So it just moved from one side of the graph to another. It's just shifted. It's like you slided it. It's like a slide. All right. The next one, I want you to attempt to do on your own. So right now, pause the video, and I'm going to have you do a couple of these throughout the worksheet on your own, and then what I want you to do is I want you to find the review sheet in the room that matches the ones that you're doing on your own. They're labeled for you. Just go up and check your answers, see what you did wrong and correct, because this is going to be better practice for you than just following a video through. So go ahead and pause the video and try number 2 on your own. So for number 3, we're doing a reflection. You could see it right here. It says reflect in the directions, but we're using the same coordinates as the triangle we've been using. So all I'm going to do is draw that triangle out. So I'm going to go over 4 up 2, draw my A point, go over 1 down 3, draw my B point, and go up 3 on the y-axis, draw my C point. So there's my original triangle. And now when you're doing reflections over the x-axis, there's just a couple formulas you should know. So the formula for the x-axis, and this would be helpful to write for your exam, is when you have an original coordinate, you change it to x negative y. Oof, pretty bad. And when you have it over the y-axis, I know that's not on this worksheet, but just in case you need it for your final, you have your original coordinate and you change it to -x. And I'll show you how to do that really quick. So since we're doing this formula, if my original coordinate of A was 4, 2, and I follow that formula that I've starred, I'm just changing the 2 to negative because it's in the y position. So now it's 4, negative 2. Same with B. I have 1, negative 3. And see how the y position is negative, so I actually just change it to positive. So 1, 3. And then C, if it's 0, 3, it now becomes 0, negative 3. So let me graph those coordinates. So 4, negative 2 is here. That's A prime. 1, 3 is here. That's B prime. And 0, negative 3 is here. That's C prime. And that's our triangle reflected over the x-axis. Now, if you ever have a y-axis, that's this one. For the next problem, we don't have a y-axis. We have y equals x. That's another formula you're going to need to know for your test. This is what I'm going to have you try on your own. The formula for this, if you have y equals x, is xy changes to yx. And that's it. So you just flip the coordinates. So if I had 4, 2, I'm going to have 2, 4 for A. All right, try this one on your own. All right, for this one, basically all you have to do is you're finding the position after you've done 2 different transformations to a figure. So let's just first focus on the original figure. So the original figure is right here. Let's use those coordinates. A is negative 4, 4, so negative 4, 4, so 1, 2, 4, that's right there. This is A. Negative 1, 2 is here. This is B. And negative 4, 1 is here. So there is our triangle C. All right. So after we've got our original triangle, we're going to do 2 different translations to see where, after we've done 2 translations, where the figure lands. So our first translation, I should do A, B, and C, write the original coordinates down. Negative 4, 4, negative 1, 2, and negative 4, 1. So on the first one, I'm taking 3 away from x and adding 2 to y. So that changes. So 3 away from x would make it a negative 7, because negative 4 minus 3 is negative 7. And 2 added to the 4 would be 6. And then if I took 3 away from 1, it's a negative 4. And if I added 2 to the 2, it's a positive 4. And then if I took 3 away from 4 again, it's a negative 7 because it's a negative 4. And if I add 2 to 1, it's 3. So those are our new coordinates. And I'm not even going to bother graphing that figure because that's not the figure it's asking for me to graph. It wants me to do another translation. So I'm going to take those new coordinates because these are my prime coordinates, which are negative 7, 6, negative 4, 4, and negative 7, 3. And I'm going to do this translation right here. So I'm taking 1 away from x, and nothing is changing on y. So taking 1 away from negative 7 makes it a negative 8. Oh, this is going to be ugly. I don't know if there's room on this graph. And taking nothing away from y just stays. And then taking 1 away from 4 is negative 5. Y stays. Taking 1 away from 7 is negative 8. Y stays. So let me Yeah, this could be off the graph. I don't know if Mr. Carpenter knew that, but I just want to separate. Here was my original first transformation, then my second transformation. So this is my A prime prime or double prime. I don't know how to say that. Let me try to graph it. We'll see. So this only goes over 6 if I'm trying to graph these coordinates right here. 1, 2, 3, 4, 5, 6. So 7, 8 would be like here, and then up 3. So it's going to be like over here is A prime prime. And then, oh no, I went up 3. Actually, I went up 6. Okay, so if I went up 6, it's actually like here. That's A prime prime. And then negative 5, 4, I think that actually can graph on there. Negative 5, 5, up 4, 1, 2, 3, 4. Here it is. That's B prime prime. And then C, negative 8, 3. That's the one I was graphing at the beginning. That's kind of like here. So that should line up with A, kind of off the graph there. All right, so that's me applying 2 transformations to a figure originally with these coordinates. So what I want you to do is come on over here and apply this translation to those coordinates and then reflect it over the x-axis using the formula I gave you on the last sheet, and then check your work. So go ahead and pause the video and try that. All right, so I'm going to come down here. Now we're getting into more circle stuff. So let's see. So we see AC, this line here, and BD are both diameters 180 degrees in the circle of F. And F's the center, so that's why we call it circle F. So we're trying to find the measure of the given arc. So for measure, that's what the M is. Some of you need to remember that. The measure of arc AB, that's what the little symbol above AB is. This measure, since F is the center, and 70 is the angle measurement, the arc is going to be the same measurement. So that's pretty simple. 70 is the arc measurement. Measurement of BC, we don't have. So let's come back. Actually, we don't have to come back to it. We know AC is 180. And if we know that this is already 70, what's the other half? So basically, I just have to go 180 minus 70. I end up getting 110. So that's the answer there. That's the answer there. All right, ABC, that should be the simplest thing ever. You should know that's 180 because ABC, that whole arc right there, is 70 and the 110 together. So that's 180. I'm actually going to keep teaching this. I'm not going to make you try any on your own because I don't want any confusion. So we're trying to find AE, right? And we're also trying to find CDE, okay. So let's see here. If we're trying to find AE, well, I already know this is a diameter, and I know this is 70 and this is 60, and AE is a piece of it. Well, 70 and 60 is 130. And so if I add that little piece that I'm missing in there to make a 180, which it does, pretty much just subtract it from 180 to figure out the piece I'm missing, which you should know is 50. So AE is 50. CDE, make sure you go in that order, C to D to E. This one now we can figure out because we know this is a diameter right here. So if I don't know this, but I now know this is 50, well, 50 and 60 is 110. And we kind of go back to, well, 110, if I take that away from 180, which we did earlier, this is 70. So CDE is, well, we had to figure out CD to figure out CDE. So if I figured out CD, CDE is 70 and 60, which is 130. And then the last one, BDC, B to the D. I actually should use a totally different color because I've colored all over this circle. Okay. B, D, C. So BDC is all of this right here. So that's 70, that's 50, that's 60, and that's 70 again because we figured it all out. So that means this is 70 plus 60 plus 50. Oh, that's a 50, but it's not. Try again. Ooh, plus another 70. So if I add all of those together, 140 plus 110 is 250. Coming off the page. That's 250. Don't judge the writing. I know you totally are. Okay, so that is how you figure out measurements of a circle, especially when you have the center identified in some of the angle measurements. All right, on this circle here, we're just solving for the variable x. And since it is an angle that goes from one side of the circle to the other, the arc, what you do is you use the arc divided by 2. So all you have to do is 70 divided by 2 to find the variable x, which would be 35. That's what happens when you have an angle measurement that goes from one side of the circle building out to an arc, like this one. Alright, on this one I'm going to give you a little challenge. I'm going to do this piece for you, and then I want you to do this piece for me. So on these, all you have to know is when there's a quadrilateral that's inside of a circle, the opposite sides are going to equal 180. So I just go 6y plus 3y equals 180. So 6y and 3y is 9y equals 180. Divide out the 9 on each side, and y equals 20. So go ahead and pause the video and start finding what 4x and 2x to equal 180 would be for x. On this circle, what you're going to need to know how to do is know that when you have an interior angle in the circle that's not the center, you're going to add the arcs and then divide by 2 to get x. So 136 plus 110, that's going to give me 246. And then to get x, I just divide by 2, and I end up getting 123. So that kind of formula would be for an interior angle in a circle, you would add the arcs and then divide them by 2. On this one, it's going to be similar with an exterior angle, so I'm going to have you try this on your own. I'm just going to set you up here. On this one, it's just the exterior angle of a circle is you subtract the arcs. And then divide by 2. So this is an arc you've already been given. This is 260. You could figure out this arc by subtracting 260 from 360 to get it. Then you're just going to subtract these two arcs and then divide by 2 to get x. So go ahead, pause the video, and try that one on your own.
Okay, so number 9 says, find the center and the radius of a circle that has the equation x plus 1 squared plus y minus 4 squared equals 36. So this follows the general model of a circle equation, which is x minus h squared plus y minus k squared equals r squared. So to find our center, all we have to do is we'll take the opposites of these numbers, because if you notice it's x minus h and it's y minus k. So our center is simply going to be -1 and +4, because the opposite of +1 is -1 and the opposite of -4 is +4. and it equals r squared. So this is our r squared. So what number squared is 36? Well, that would of course be 6. So the radius would be 6. Okay, in problem 10 it says if QR is a radius of circle R and PQ is tangent to circle R, find the value of x. Now remember, if something is tangent to a circle, we know a couple of things. We know it meets at one point on the circle, and also it is perpendicular to its radius, so it has a 90. So we have this little right triangle that we can apply Pythagoras' theorem. So if you look at this triangle, this RQP, that has to be a right triangle. Now in this right triangle, 26 is the hypotenuse, because it's across from the 90, and then 10 and x would be legs. We don't really have to worry about opposite and adjacent because we really don't have to do the trigonometry. We can just do our basic Pythagorean theorem. So we can set this up as x squared plus 10 squared equals 26 squared. So we know 10 squared, 10 times 10 is 100. And 26 times 26 is 676. So since I'm trying to find one of the legs, I'll subtract from 100. So that's going to be x squared equal to 576. So I'll take the square root. So the square root of 576 is actually a nice number. It is 24. So this segment PQ would have to have length of 24. And that's all based on the fact that PQ was a tangent segment to circle R, which means it's perpendicular, making that right angle to radius RQ. So if we look at this next one, it's a very similar problem. So what I'd like you to do, go ahead and pause your video. Go ahead and try this problem. Try to find value x, just like we did in the previous problem. And then you can input your answer and check it. Okay, our last couple of problems are going to come from the concept of probability. So the first problem says if a spinner with three colors, green, red, and blue is spun, then it is spun again, find the following. So the first asks for what is the sample space. So remember, the sample space is everything that can occur. So if you think about it, I'm going to spin this spinner. I'm going to get red, or green, or blue, and then I'm going to spin it again. So if I got a red the first time, I can get a red, a green, or a blue, or a red, a green, or a blue if I got green first, or if I got blue first, the same thing. So I have basically 9 outcomes, and I can list those to make my sample space. I can get 2 reds, I can get a red then a green, I can get a red then a blue, I can get a green and then a red, I can get a green and a green, I can get a green and a blue, I can get a blue and a red, I can get a blue and a green, and I can get a blue and a blue. Now based on that very easy little sample space, I could do most of the problems that are going to be associated with this problem. Okay, in question 12 it says, what is the probability of me getting at least 1 red? So we know that there are only 9 possibilities, so my probability will be out of 9. So if I look up here, I'm thinking how many of these have at least 1 red? Well, this one does, this one does, this one does, this one does, and this one does. Each of those has at least one red. Now the first one has 2 reds, but that still counts for at least 1. So 5 out of the 9 outcomes contain at least 1 red, so the probability of getting at least 1 red is 5 out of 9. Now if you look at 13, it's a pretty similar problem, pretty simple one. It says if we have 1 red, what's the probability of getting 2 reds in a row? Well, if I look up here, I only see one outcome where I'm getting 2 reds in a row. Only can happen one way. You get a red, then another red. So the probability of getting 2 heads in a row is 1 out of 9. Now we can do that the old way of multiplying, saying what's the probability of getting the first red? Well, that's 1/3. What's the probability of getting another red? It's 1/3 again. 1/3 times 1/3 is 1/9. But when you have the sample space, you can really just kind of simply look at what outcomes hold and go from there. Okay, so let's look at number 13. It says, what is the probability of getting 2 of the same color? So I'm going to go ahead and let you try this one. Look at your outcomes here in the sample space above and try to see what is the probability of getting 2 spins of the same color in a row. All right, moving on to problem 15, it says, what is the probability of getting a red given you already have spun a green? So it's saying I have spun a green, and what's the chance of getting a red? Okay. So if I spin a green on my first spin, so I've spun a green. So if I look at my outcomes, I've spun a green already, so I know the only ones that would count are one of these 3 outcomes. It's either going to be green, red, green, green, or green, blue. Because what it says is it says I've already spun a green. So it's already happened. It's already occurred that I've spun a green. So out of those 3 outcomes, what's the chance that I get a red? Well, that would simply be just 1 out of 3. Because out of those 3 ones where I've already spun a green, only one of them has a red that occurs as the second spin. All right, 16. 16 says, are the events getting a red and getting a second red independent? Do they influence each other? So if I spin a red, we know the chance of getting a red on this spinner is 1/3, right? So we have 3 equal spaces. So there's a 1/3 chance of getting a red. Now if I spin it again, what's the chance of getting a red? Well, it's still 1/3. So these are independent because they do not influence each other. Now things like drawing cards out of a deck, those would not be independent because you have less cards when you draw, say, a queen out of the deck. Okay, let's look at this last problem. It says, are the events getting red or blue mutually exclusive? And this one is a pretty easy question because the answer is no. And the reason I know it's no, mutually exclusive means can they occur at the same time? Well, is it possible to get a red and a blue at the same time? Well, of course it is. If I get an R or a B or an R, then of course that is saying that those occur at the same time. So the answer is no, they are not mutually exclusive because they can occur at the same time. Alright, so this was your last review for your final exam. Please let us know if you have questions.